All right. So once again, a very, very good evening to you all. It's a beautiful thing for us to meet again to look at the concept of networking defense. And in the last class, we were able to look at Module 3, which was talking about access control. And that module is centered on our ability to be able to protect our network so that unauthorized users do not have access to our network. Okay, so basically that is what we did. So we looked at different ways that you can secure your network, both physical, logical, administrative, and so on and so forth. Now, Module 4 is talking about access control lists. This is going to be a little bit technical, but before we go into the technicality, I want to bring your mind to the concept of what we call IP addressing and subnetting. An IP address is a unique number that every device that must belong to the network has. So if I have a phone and that phone wants to talk to the network or belongs to the network, it needs to have that IP address. It's just an identity, it's just a number. Okay? Now, it is that IP address that identifies that system that is used to control the traffic, where the traffic goes. So if your traffic is moving from point A to point B, if your traffic is moving from point A to point B, the IP address is used to determine the source and the destination. Okay? So you'll say the source of your traffic, then you give the IP address, the destination of your traffic, that's the IP address. So that IP address is what is being used to identify. So generally, if I want to control my traffic or the traffic on my network, I will be dealing with these IP addresses. That's how I identify the computers. Now, in access control list, what we're going to be talking about basically is just how to do two things: how to permit and how to deny. You want to permit a set of systems to access a particular set of resource, or you want to deny a particular set of systems to access a particular resource. So that's what we're going to be dealing with. So the first thing I just needed to prepare your mind, we're going to be talking a lot about IP addressing. The second thing we're going to be talking about is a concept called the wildcard mask. The wildcard mask, we'll talk about it soon. Now, for those of you who do not know what a wildcard mask, on a normal day, when your system gets an IP address from a DHCP server, it gets what we call a subnet mask. The subnet mask is just the set of numbers that identifies that system to a particular network. So it's like the surname, okay? It's what determines the network portion of that particular IP address. That's the subnet mask. Now, the subnet mask helps you to say, oh, this system belongs to this family. This system belongs to this family. That's just what the subnet mask does. Now, the wildcard mask is the inverse of the subnet mask. What do I mean? When we talk about wildcard mask, it is the opposite of the subnet mask in terms of the numbering. So we're going to get to it very, very soon. So I just needed to lay that before we go in. So in this particular topic or module, we'll be splitting it into two. We will do part today, and then tomorrow we will do the second part. Remember, tomorrow is Wednesday. Our class is going to be 6 to 8. Okay? Thursday, our class is also going to be 6 to 8. So I implore you to join. So we'll do the first part today, and then tomorrow by 6 to 8, we'll do the other part, okay? Now, so we're going to be introducing the access list, and we'll describe the two types, what we call the standard and the extended. Then we will talk about the concept of the wildcard mask, and we will explain how access lists use wildcard mask, okay? Then we will also see how to configure access list. Then how do you modify the access list? How do you implement the access list? And how do you mitigate attacks with access list? Then IPv6 access list. So like I said, we'll look at part of it today. Then tomorrow we'll look at the other part, okay? What is an access list? An access control list is a series of iOS command. When you say iOS command, we're talking about Internet Working Operating System command. In other words, it's a command that you use on routers or switches or so. So it's an iOS command that are used to do what? To filter packet based on information found in the packet header. The packet header is the encapsulated portion of the data that contains some other information about that data. Talks about where the data is coming from, where it is going to. Talks about the port that is going to use. Talks about the MAC address is going to use. Talk about all the encryption, the security. Talks about everything about that data. That is what is in the packet header. So basically, the access control list is going to be dealing with that. By default, a router does not have any access list configured. So you need to configure it. However, when an access list is applied to an interface, the router performs the additional task of evaluating all network packets as they pass through the interface to determine if the packet can be forwarded or not. Remember, as I said in the introduction, it's all about permitting or denying. All right, you want to permit this IP address to access this resource, or you want to deny it. That's just basically it. So an access list uses a sequential list of permit or deny statements. Very key, sequential lists of permit or deny. When we say something is sequential, it means that it takes one, then after the other, and then after the other, and then after the other. That is the concept when we say sequential. So, it has to do A before it goes to B, before it goes to C. So the order in which you write your access list statement matters a lot, okay? Now, when network traffic passes through an interface configured with an access list, the router compares the information with the packet against the access control entries, okay? ACE means access control entries in sequential order to determine if the packet matches one of the access control entries or not. Several tasks performed by routers require the use of access control lists to identify traffic. So the table lists some of these tasks with examples based on corporate policies. So for instance, there's what we call limit network traffic to increase performance. Maybe you notice that your network has a lot of bottleneck. It's very slow, it's very slow. So what can you do? You can now say video traffic is prohibited on the network to reduce the network load. A policy can be enforced using access lists to block video traffic. So you see, you say, okay, I want to block people from accessing YouTube or from downloading anything video or for downloading anything this. Then you write an access list statement. All right, you configure an access list. Or another one, provide traffic flow control. Routing protocols traffic should be limited to certain links only. Okay, should be limited to certain links only. A policy can be implemented using access list to restrict the delivery of routing updates to only those that come from a known source. All right. So very, very important. Then you will be able to do it. You know. Now, sorry. Another one is provide a basic level of security for network access. Access to human resource network should be restricted to authorized users only. A policy can be enforced using access lists to limit access to specific network. For instance, I don't want people in production department to be able to access network in accounts department. Okay? Or maybe in your organization, you have Wi-Fi. And then you have maybe guest Wi-Fi, you have staff, and then you have others, maybe students or any other one. Then you can create an access list to prevent guests, people who connect to guest Wi-Fi, they will not be able to access certain resources. Or those who connect to students' network, Wi-Fi may not be accessed, will only be restricted to access certain resources. That is what we are saying. You use access list for that. You can also use access list to filter based on traffic type. When we say traffic type, we're talking about the protocol that is used on that traffic. The protocol. What is protocol? The rules. For instance, you can say web. The web that you use to browsing. What protocol do you use? HTTP. So you can create a filter based on HTTP or HTTPS. You can also create it based on FTP to say you want to stop people from transferring files, or you want to allow only people from this segment to transfer files to this segment. Or you want to use it based on maybe mails, SMTP. So whatever service that you want to do, there's a protocol that works on it. So that's the traffic type. Okay. So another one is to screen hosts to permit or deny access to network services. So access to some file types should be limited to user group. A policy can be implemented using access lists to filter user access to services. Provide priority to certain classes of network traffic, what we call quality of service or QoS. So the QoS is designed based on either voice, video, or data. So whichever one, voice, video, or data. So you can create priority to say, oh, I give more priority to video or to voice or to data, depending on what you want to do. Packet filtering is centered based on layer 3 and layer 4 of the OSI model. Remember, we talked layer 1 is the physical layer, layer 2 is the data link layer. And in layer 1, this physical layer, because it deals with just cabling, okay? Your cabling, how your network is connected to how your system is connected to the network, whether it's wireless or cable-wise, and how all those things. Data link deals with basically your switches, and it has 2 sub-layers. It has what we call the logical link control, and it has what they call the media access control layers. Okay, so it has those 2 layers, and then it manages, but the device that works on there is the switch. Then your network layer, the device that works there is basically the router. So what it does is that it does packet forwarding and path determination and packet forwarding. And the layer 4, what happens there is not a device, it's a protocol. The protocol that runs there is the TCP and UDP. So it's the port. So when it comes to cybersecurity or network security or network defense, basically our area of concern is these two, layer 3 and layer 4. Why? Because packet filtering is dealing with how the behavior of traffic and where it's routed and how it goes. Okay, so Cisco router supports two types of access list. There's what we call the standard access list, and there's what we call the extended access list. So we'll be looking at those two. Now, I don't want you guys to be confused, because we're going to be talking about a lot of new things. Remember, I said access list is all about permit and deny, agreed. Now, we're saying that there are types of access list. There's what we call the standard access list, and there's what we call the extended access list, agreed. Now, you're going to see that there's another one called the named access list and the numbered access list. So the name and the numbered can go for both standard and extended. We're going to get to that. But what is this standard and what is extended? Standard access list only filters at layer 3. And what does it use? It uses the source IP version 4 address only. That is the standard access list. It functions on this layer. The standard access list functions at that layer. And what does it use? It uses the source IP address. So if, for instance, I want to write an access list to prevent all the computers in human resource from accessing the FTP server, then I will create an access list using the source IP address, and it's going to be the source IP address coming from human resource. Okay, that is standard. So don't forget, it functions at layer 3 and it is based on source address. Then the extended IP address access list filters at layer 3 using source and destination IP address, and they can also filter at layer 4 using TCP and UDP port information. That is the extended. The extended is trying to say it can do what the standard is doing and even more. It can do what the standard is doing and even more. That is the extended, right? Now, there's also what we call the numbered and the named access list. Remember what I told you. When you say the numbered means that when you are configuring this access list, you are just using numbers to identify the lists. If you say named, that means you're using names to specify the lists. So you can have a numbered access list of standard and extended. You can have a named access list of standard and extended. So when you are doing numbered access list, how do you know which one is standard and which one is extended? How you get to know is from the number, the numbering. Once in your configuration, you use anything from number 1 to 99 in configuring your numbered access list. Or you use from 1300 to 1999. That means the system will know you are using a numbered access list. Remember, the numbered access list can be standard or extended. For standard, you use 1 to 99 and then, or 1300 to 1999. We will see examples on how to do that. Then for the extended, you will use from 100 to 199. Yeah, so you see, when you do standard 1 to 99, you stop at there, then you continue from 100 to 199. That is extended. Or you use from 2000 to 2699. That is it. So usually when you're configuring it, you go into your router, you say access list, then you specify the number. Yeah, you specify the number. If it is a standard access list, you can use any number between 1 to 99. So you say access list 10, access list 15, access list 99, access list 83. You can use any number between 1 to 99. Is standard. But the moment you say access list and you say 100, the system will know it's extended. Or access list 115. Or access list 120. Whatever you use that is extended. All right? Now, for the named access list, it is the preferred method to use when configuring access list. Specifically, standard and extended access lists can be named to provide information about the purpose of the access list. About the purpose. The IP access list global configuration command is used to create a named access list. Now, when we say name access list, what do we mean? You see, like the other one, you want to configure the access list. You say access list, then you give the number. Access list 10, access list 15, access list 20, access list 200. You are using numbered access list. But in the named, you don't use number. You write a name to explain what you are using. For instance, it says IP. Now, when you are doing it, you have to use this. Instead of access list, you say IP access lists. So IP access list, if it is standard, you write standard. If it is extended, you write extended. So you see in this case, you put extended. If it is standard, you just put the access list and then you now put standard. But now you have put extended, then you will put the name that you want to use. Any name you can create. Okay? So IP access list, extended, FTP filter. So after you write that, the router automatically notices and it changes its prompt. You will see it will give you something that looks like EXT, which is extended. Extended. Then you see NACL, which means named access list. Name access control list. So that's what the router will show you. So once you see that, you know that you're using a named access control list. So you will now give your own command. So in this example, you give a command, permit TCP, then you give the IP address. Then the wildcard mask, we'll talk about it later. Then you go give the destination, we'll talk about it. So the rules to follow for a named access list. What are the rules that you will follow? 1, assign a name to identify the purpose of the access list. In this example, the purpose is to filter FTP traffic. So that is 1. 2, name can contain alphanumeric characters. Alphanumeric means can contain alphabets, contain numbers. 3, names cannot contain space or punctuation. That is why you see in this case, they use a hyphen to connect the two words. All right? Then, number 4, it is suggested that the name be written in capital letters. Capital letters. And then, finally, entries can be added or deleted within the access list, which means even if you've created, you can remove it, you can change it, you can alter it. But the fact you've created it does not mean that is all. So that is for name. So you see, we have looked at standard access list and extended. We have looked at named access list and numbered. All right. Now let's look at the operation, how the access list works. Because the whole essence of this access list is to either permit traffic to pass through your network or deny it. That's all. Access control lists define the set of rules that give added control for packets that enter inbound interfaces, packets that relay through the router, and packets that exit outbound interface of the router. So access lists can be configured to apply to inbound traffic and then to outbound traffic. So when you are configuring your access list, when you say inbound traffic, you are trying to say traffic that comes into your edge router or into the router generally, any of the router. So like in this, you see where this arrow is pointing, traffic that comes into, so the interface here, when you are applying the access list there, you know that you are applying it for an inbound traffic. But if you are applying the access list to this interface here, that means you're applying it to a traffic that is going outside your network. So if you are saying, I want to deny traffic coming from maybe marketing to go through audit. So if the traffic coming from marketing comes here, it will be dropped here. It will be dropped. It will not even be allowed inside the network. But if you are saying you want to stop your users that are in audit from browsing pornographic websites or from browsing or downloading videos, so you see the traffic you're doing, you are blocking them before they go out of the router. Okay, so whichever way. Now, inbound access, it filters packets before they are routed into the inbound interface. It is efficient because it saves the overhead of routing lookup if the packet is discarded. If the packet is permitted by the access list, it is then processed for routing. Best used to filter packet when the network attached to an inbound interface is the only source of the packet that needs to be examined. So the concept of using the inbound here is to reduce overhead work for the router itself. How outbound? It filters packet after being routed, regardless of the inbound interface. So the traffic has been routed. So as it goes out, that is where the filter is applied. Incoming packets are routed to the outbound interface and processed through the outbound access list. This one is best used when the same filter will be applied to packets coming from multiple inbound interfaces before exiting the same to the outbound interface. So when the access list is applied to an interface, it follows a particular or a specific operating procedure. The operational steps used when traffic has entered a router interface with an inbound standard IP version 4 are configured. All right. Then the router extracts the source IP version 4 address from the IP, from the packet header. All we're just saying, we're just trying to explain what happens, okay? From the time the traffic comes and then when the traffic is going. All right. 2 says the router starts at the top of the access list and compares the source IP version 4 address to each of the access lists in the sequential order. What do we mean here? That in the router, let's assume this is the router. And this router, you have configured an access list inside the router. So since it's a list, let's call it like this. So this is the first 1, 2, 3, 4. So there are 4 access lists inside this router. And that 4 access lists, they are just instructions. So don't think about it as it's something big. It's just instructions that are written there. So after you've written it in the router, then you will come and apply it on the interface, either on the inbound interface or on the outbound interface. So what we are saying in point number 2 is that the router starts at the top of the access list and compares the source IP version 4 address to each statement. So it will now look at the source IP address and then checks if it meets the statement, because the statement that you are putting, you say, okay, any traffic coming from marketing, block it from going to insurance or whatever. Any packet coming from this, from natural science, don't allow it to go to engineering. Okay, that's the statements you are putting. So when the traffic comes, it uses that IP address to check where is this IP address coming from. If you say, oh, the IP address is coming from natural science, then this list is applied to it. So what it does is that it checks from the top. It checks number 1 first, then number 2, number 3, and then number 4. So it does a top-bottom approach. Now, when a match is made, the router carries out the instruction, either permitting or denying the packet. And the remaining access list statements in the access control list, if any, are not analyzed. So if it matches the first one, all the others don't matter. It just applies the statement. All right. So if the source IP version 4 address does not have match in the statement, the packet is discarded because there is an implicit deny that is automatically applied to all. When we say implicit deny, what we simply mean is that by default, it is configured to deny traffic. So your access list statements is to permit, or you want to deny some, you deny some and stuff like that. Any other one that does not fit in is denied. That is just the point. Now, let's talk about wildcard masking. Wildcard masking. Okay. Now, okay, good. Wildcard mask overview. An IP, okay, before we go into wildcard mask, I want to confirm if you guys are following. Is there, do you understand what we have done so far? Or do you have problems, or you need clarification? Am I going too fast, or are we just okay? Let me just get your feedback so that we don't get too lost. Are we okay? Let me check messages. All right. Okay. Are we okay? Is there any challenge? Or are we good to go? Okay. All right. Thank you, Ikoi, for your message. All right. T. Thomas Root, thank you also very much. You said you are very okay. Ada Cletus, thank you very much. I think you're all good. So from what I see here, we are all okay. We're all understanding, which is very good. So now we're going to continue. So we're going to another dimension now. That is the wildcard mask. Okay. Now, just a minute. All right, so let's continue. Okay, now, sorry for that silence. I was just taking care of something. Wildcard mask. Just a minute. Let me. Okay. So an IP version 4 access control entries uses a 32-bit wildcard mask to determine which bits of the address.
Sorry, I actually asked a question. Maybe you didn't read it.
Oh, okay.
On the platform.
All right. So let me check. All right. I have a question from Ikoyi. Says, can you throw more light on implicit denial? All right. Very good question, Ikoyi. Now, what example should I use now? Okay. Let me assume that in a class, we have people that are of age 1 to 5. Then we have 6 to 10. Then we have 11 and above. Now, I can write an access list statement and say, I want to permit any student with age bracket, either 1 to 5 or 6 to 10. That is just what I'm saying. I didn't say deny anybody. I only say permit any student into the class that is within the age 1 to 5 or 6 to 10. What does it mean? It means that any other person that does not fall within this age group is automatically denied. That is what it means by implicit denial. The implicit denial simply means you must not need to mention it. It is there by default. So, if for any reason there is an exception of a particular student that is 17 years old, and you want to permit that particular student into the class, you can say, permit student A with age 17. Then permit any other student that is less than 10 years old, or less or equal to 10 years old. Bam. So you see, you have exempted 17. You say, okay, permit any student with 17 years old. Then any other student that is 10 years old and below, permit. Which means any other person outside the bracket will be denied. That is what it means by implicit denial. Okay? That is what it means by implicit denial. All right, so I want to believe that has answered it. Okay, let me see. All right, so I think it has answered it. Now, it says an IP version 4 access control entries uses a 32-bit wildcard mask to determine which bit of the address to examine for a match. Wildcard masks are also used by OSPF routing protocol. Okay, let's continue. I'll explain all that. A wildcard mask is like a subnet mask. Sorry. A wildcard mask is like, why does it keep going back? A wildcard mask is like a subnet mask, and it uses what we call the ANDing process to identify which bits in the IP version 4 will match. However, they differ in the way they match binary 0s and 1s. Don't worry, I will explain all that. Unlike a subnet mask in which binary 1 equals to a match or 0 is not a match, a wildcard mask, the reverse is true. Now, originally, right, this course requires that you must have done networking fundamentals or networking basics. And particularly, there is a topic called IP addressing and subnetting. But I know some of you have not done that. Some of you have done. So those that have done networking, I'm sure you understand what we're saying here. But those that have not done networking, there are just 3 things I want to explain here. Number 1 is that there is what we call static routing and what we call dynamic routing. Routing is simply deciding which path your traffic will follow. You want your traffic to follow left, right, or center. It's determining. You are the one to determine. If you create static route, that means you are the one that is manually deciding for the router to say any traffic that is coming from here, if it is going to this destination, follow it here. Whether he likes it or not, whether there is fire on that port, allow it to go through that. You are the one deciding. Then dynamic routing, you are telling the router, I trust you to take this decision. But for it to take that decision, it needs what they call routing protocols. You need to configure the dynamic routing protocols. And we have different types of dynamic routing protocols. We have what we call the RIP, Routing Information Protocol. You have another one called the OSPF. It's called Open Shortest Path First. Then you have another one called the EIGRP, Enhanced Interior Gateway Routing Protocol. You have another one called the BGP, Border Gateway Protocol. You have another one called the IGP. You have IS, you have different routing protocols. So these ones, they are all dynamic routing. If you configure, I don't want to go deep into them, but it's a topic for another day. But if you configure any of these routing protocols, dynamic routing protocols in your router, which means you are telling the router, I trust you to use this protocol to decide which path to forward the traffic. So here, we're saying that wildcard masks are also used by OSPF routing protocol. That's just the point that one is making. Now, this issue of ANDing process here, remember at the beginning of the class, I told you that wildcard mask is the inverse of what do you call it, subnet mask. What is a subnet mask? A subnet mask identifies the network portion of the IP address. So for instance, let me share my screen again so that okay. So I want to believe you can see this black screen here. Now, if I do IP config here, it will show me the IP configuration details of my laptop. Look at it. It's telling me that my laptop has these IP details. There are these three. Forget about every other thing. Look at these three. Let me highlight them from here. Look at these three. The first one is called IP address. It is the unique number that identifies my system on the network that I'm using now. The second one is the subnet mask. The subnet mask, you see it, is the number that identifies the family name, which means any computer that is connected in this my house with this same network is going to have the same family name. It's like a father that has 10 children. All the 10 children will carry the same surname. That's the family name. All right. Now, the wildcard mask is the inverse of this family name. And what we are saying is that anywhere there is 0, we replace with a 1. Anywhere there is a 1, we replace with a 0. But if you observe here, there is no 1 or 0 or whatever, because this is in decimal. So you are to convert it to binary. If you convert it to binary, you will get the inverse. All right? You will get the inverse. So we're going to do that together. All right. So how is this conversion done? If, for instance, my subnet mask is 255.255, like you have seen, .255.0. All you just need to do is you subtract it from entire 255. So just put another 255 at the top here. 255.255.255.255. So you do the subtraction. 255 minus 255, you will get 0. 255 minus 255, you get 0. 255 minus 255, you get 0. 255 minus 0, you get 255. Now, this is the wildcard mask for this subnet mask. That's the wildcard mask of the subnet. Just subtract everything from 255. I've just shown you the simple way. I didn't want to go through the binary expansion. That one is for another day. I'm just using this because I know there are some people that probably did not do networking. Right? Good. So wildcard mask use the following rules to match ones and zeros. All right. Where there is a 0, you get a match, a 1, and things like that. That is using binary. But I've just shown you the shortcut. Just whatever your subnet mask is, subtract it from 255 all through, and you will get your subnet mask. For the sake of the binary, you can convert your whatever it is to binary. If you convert it, then you can get your answer. So let's not worry about all this. You see, if you see this like this is a wildcard mask. If you see this like this is a wildcard mask. If you see this like this is a wildcard mask. You see this is a wildcard mask. So if I ask you what is the subnet mask for it, remember, for wildcard mask, just subtract it from 255. Maybe you have 255, 255.0, .255, and you subtract it with a wildcard mask with 255.0. If you subtract, you're going to get 0.0.0.255. Now, if you have this as a wildcard mask, how do you get back your, what do you call it now? Your original subnet mask. How do you get your original subnet mask? It is very, very simple. It's very, very simple. All you just need to do is that you do the inverse. You do the inverse. All right? So you subtract it from 255. So if you do the subtraction, it will be 0 minus 255 will give you what? 255. Then you have 255. 0 minus 255, you have 255. 0 minus 255, you have 255. Then 255 minus 255, you will have 0. So it will bring you back to your original. Right? So I see someone has typed in a question. Okay, somebody says you will add. No, not necessarily you add. If you add, by the time you get to this last octet here, because you will have 255, if you add, you'll get 512 here. So it's supposed to be a subtraction. Okay. So if you have time to go through the binary, that would be excellent. All right, but I don't want to go deep into that. So I'm just giving you the shortcut because to avoid confusion, right? But everything can be converted to binary. Okay. Okay, this is the calculation that we're talking about. This is your old 255. So you minus from this is a subnet mask. Then you will get this wildcard mask. So if you have this wildcard mask, you want to get back your subnet mask, then you subtract from 255. All right? Subtract from 255. So this is the same thing. Now, Cisco iOS provides 2 keywords to identify the most common use of wildcard masking. There's what we call the host, and there's what they call the any. Host, it substitutes 0.0.0.0 mask. This mask states that all IPv4 address bits must match to filter just one host address. Any substitutes for all 255 masks. This mask says to ignore the entire IPv4. What it means, for instance, is that if I'm writing an access list and I say access list 10, now access list 10, is it a standard or extended access list? This one, access list 10 and access list 11. Is this a standard or an extended access list? Anybody? Let me see.
Yeah, it's standard.
All right, that is good. It's standard.
Standard.
Correct. It's standard. Now, is it a named or a numbered access list?
It's a numbered access
list.
list.
It's a numbered access list. So we have a standard numbered access list. All right. So you see, it says access list 10 permit this IP address. Remember, standard access list makes this decision based on the source IP address. So permit this IP address. So usually you will now say permit source address, and then the host, the destination that you want to permit it or something, or source address and then the subnet mask, depending on how you want to put it. So here you say permit this, and then you use this particular IP. Yeah? You are saying permit this guy and then the subnet mask, because what is supposed to follow here is the subnet mask or the wildcard mask. All right. You are looking at this wildcard mask. So instead of using this, look at it. You use the word hosts. That is what is, that's the point that is being mentioned here. Instead of this, you use the word hosts. And then this is another one, access list 11, permit, and you are saying permit this guy, and then this is the source. Anybody going anywhere. This is anybody. That's why it says permit any. Okay. So why we're saying it here is there is a time we will use it interchangeably. All right. Now, configuring access lists. Now, all access lists must be planned, especially true for access lists requiring multiple access lists. It must be planned. In other words, you are creating a filter on your network. You don't just come in and start creating filter. You must have made your plan. Say, okay, this is what I want to do. I want to permit this. I want to stop this. So that is 1. 2, when configuring a complex access list, it is suggested that you use a text editor to write out, maybe something like a notepad. Write out your commands first, because I'll not lie to you. There are instances that you begin to configure access lists and you will lock yourself out of the network. Just when the network you are busy configuring, because you want to secure it very well, you just lock yourself. And you lock yourself, you cannot come in. You have implemented a command that is blocking you, and how to get it back becomes a problem. Or you have implemented a command and is blocking maybe your chief executive or somebody, and you don't even know. So it's suggested, especially for complex access list, write it on a notepad and go through it over and over and over to understand. All right. And then add the configuration commands to accomplish those tasks. Then include remarks to document your access list. That is a very important rule in all networking. Networking generally, documentation is key. Okay? Documentation is key. So anytime you are doing firewall or security or whatever it is you are doing, documentation is key. So your access list statements, you need to document them. Copy and paste the command into the device, and then always thoroughly test the access list to ensure that it correctly applies to the desired policy. In fact, in some organizations, we advise them to use like simulators, like the packet tracer that you're using is a simulator. You can simulate it, simulate your network, and then test these rules and see the behavior before you carry it and go and deploy in a live organization. Yeah? right. Numbered standard access list syntax. Syntax means the format. You know, when you are writing the access list, what is the format you're supposed to go about it? One says, to create a numbered access list, use the following global configuration command. You are already in the router. This is what you're going to see in the global configuration mode. Then the syntax is you will type the command access lists. Then the access lists number. Now, the access list number tells you whether it's going to be a standard access list, extended. So, but in this case, we're looking at the standard. So our number should be maybe between 1 to 99 or between 1003 to 1999, right? So access list, then you specify the number. After that, then you use the keyword. Is either you use deny or you use permit, or probably you use remark. Remark is when you are doing documentation, you want to give like an explanation to the access control list. Okay, you want to give an explanation. That's what you do that. So you say access list 10, then you say deny. Yeah. So that's the syntax. Now, when you give that deny, then you give the source IP address. You give the source IP address, right? After the source IP address, then you give the wildcard mask of the source. All right? Once you give the wildcard mask of the source, that is it. If you want to log it, to give a log, then you give a keyword to generate an information message. All right? So that is it. So if you want to remove the command, just use no in front of it. So no access list, then you give the access list number. Press enter, and then it will remove it. Very, very simple. So access list 10, deny 192.168.1.1, wildcard mask 0.0.0.255. Press enter. Chicken. Okay. So to create a named access list, use the following global configuration commands. Still yet, you're in global configuration mode. What you do is IP access list, then you type the keyword standard to tell you that you want to do a standard access list. After putting standard, then you now give the access list name. The name should describe what you are doing. It's like saying FTP transfer or prevent, deny HTTP or something. Create a name, right? So once you do that, this command enters the name standard configuration mode where you configure the access list. The access control list names are alphanumeric. We have said that, right? So this is like an example. So you see for the named access list, look at it. You say IP access list, standard, and then you now give, like here it says no access. Now, the beauty about the router is that it can help you in case you forgot. All you need to do is just type a question mark. If you say, for instance, IP access list, and you don't know what the next command is, just type a question mark. It will give you a list of options that you're going to use, that you could use in any of the segments, all right? How about extended? We have seen the standard for both named and numbered. Let's look at extended. We'll see numbered and we'll see named. For extended, access lists, then access list number. Then you do your permit, deny, blah, 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 blah. You see, from here to here is the same thing as the standard. But where is the difference in the extended? Here, which is the access list number, then the protocol, the protocol source, wildcard, then the destination, and then the destination port. Now, the protocol source is trying to say if you're using HTTP, HTTP is port 80. Now you are dealing at layer 4. HTTP is port 80. FTP is 21. DNS is 53. SMTP is 25. POP is 110. All of these services, they have their port number. So you need to know which source port number you are denying or you are permitting. If you want to remove it, just use the no access list and it is then removed. All right. Now, it says that the command to apply an extended access list to an interface is the same for standard. Remember, I said this is something like the router. The access list is going to be inside the router. It's just a list of statements that you write. After you have written them, you need to come to the interface, the port in the interface, and apply it. And you apply it to show the direction, whether it is inbound or it is outbound. So that's the point we want to make here. It says that the command to apply the access control list to an interface is the same for both standard and extended. So what is the command? Just type, you have to go to the interface mode. That's why you see this config if. So if you go to the interface mode, you just type IP access group, then you give the IP access number, the access list number, if it is a numbered access list, or the access list name, if it is the named access list. Then you type either in or out. If you want to remove it, it's the same thing. All right. So now, all right, these are port numbers. So I will pause here and then we will do, let me take one packet tracer so that tomorrow we will continue, and then because this particular activity has about 6 packet tracer activities. So I just want us to do one now, then tomorrow we can do like 2 packet tracer activities, and then you guys will do the remaining. So let me see. Good. Let me share. Okay. So now what you have here is a packet tracer activity for a named access list. Look at it. We have this activity. Configure and apply a named standard access list. So we're going to follow it one by one. We'll just follow because we don't know. So we'll follow and learn. Then we'll verify the implementation. All right. And this is the topology here. This is this router, and then it's connected to 4 networks. Switch 0, switch 1, switch 2, switch 3. So you see under switch 0, is a different LAN, different network. There's PC2, and then there's PC0 here, and PC1 here. Then there's a web server and a file server. Up here is the addressing table, is the IP addresses for each of the devices. So we'll get to it. So let's look at our scenario. It says the senior network administrator has asked you to create a standard named access list. So there are two things. One is a standard access list. And then two is a named access list, right? To prevent access to the file server. This is the file server. We want to prevent access. Who are we preventing? Since the file server contains the database for the web applications. Only the web manager workstation PC1 and the web server need to access the file server. All other traffic to the file server should be denied. So you see, it's only this PC here, this web manager on PC1. This is the only guy here that is permitted to access this file server. Every other person should be denied. So that's our job. So part 1, configure and apply a named access list. How do we do that? It says, verify connectivity before the access list is configured and applied. All these workstations should be able to ping both the web server and the file server. So let's do the verification. What is the IP address of the file server? See the IP address of the file server here. So let's copy it. So all the PCs they say should be able to ping it. So I'll just come to desktop here, command here. I will say ping, paste this IP address, and let us see. All right, so very good. So PC1 can reach it. Let's see PC0. Ping this. Okay, PC0 can also reach it. How about PC2? We'll ping it. All right, so PC2 can equally reach it. So you see, all these PCs can reach this file server. And I presume they can also reach the web server according to the statement. So let's see. Right, so you see, they can reach, this one can reach the web server. How about this guy? Can also reach the web server. How about this? Can also reach. So you see, we have verified and all the workstations are able to reach. So we are done with this. Then step 2, configure a named standard access list. How do we do that? All right, very simple. So I will go to router 1. Remember our task. It is only this PC that should be allowed to reach this file server. Every other one, this other one should not be allowed to reach it. Good. So we enter router 1 and type the command. Since it's a named access list, we'll start with IP access list. And then since it's a standard access list, we will say standard. Is that not so? Then we will give it a name we choose. And here they are using file server restriction. All right. So let's go into it. This is it. So this is my router here. You see, I'm in the user mode of the router. If I put enable or EN, it takes me to the privilege mode, but my configuration should be in the global configuration mode. So I type config, right? So you see, I'm in the global configuration mode. Why you see this config, right? So What do? I will type this IP access list. Now, assuming I don't even know, the next command to put is standard. Assuming I don't even know how to do that, I'll just put a question mark. You see, if I put a question mark, you see, it will tell me that I have two options, either to use extended or to use standard. It will tell me. So what I'll just do is standard. Once I type this, I can tap it and then it will complete it for me. All right. So the next thing is to put my name. So assuming I don't know what the next command, if I put question mark, you see it says word. So I will put it in word. What is the word that we say they want us to use here? Let me just copy this one. File server restriction. Okay. File server restriction. All right. So I press enter. So this is where we are. Now, the next thing, if you observe, see the prompt has changed. It's telling me that I am in a named, a standard access list, and it's a named access list. And you see standard. If it is extended, you will see EXT. Okay. So I am going to now say permit hosts 192.168.20.4. Who is 20.4? 20.4 is this PC. Can you see? This PC1 is 20.4. Who is PC1? That's the web manager, because that is the instruction. We're supposed to permit 20.4. And then we're also going to permit the web server. See the web server here, 100.100. Then any other host will deny. All right, so let's write the command here. So I type permits hosts 192.168.20.4. And then permit host 192.168.100.100. All right. Then deny any. Remember, I told you when we're going to use any and when we're going to use host, what it means. Okay. All right. So we have done that. You see, we have created an access list, and it's a standard access list. Look at it, IP access list standard. Then we gave it a name. Then we permitted these two devices, and we denied any other device. But remember, we have just created the list. We have not applied it to the interface. All right. Now, let me ask this question. Let me see who is smart enough to tell me. This is router 1. Which interface should we apply this particular command? Is it interface for switch 0, or interface connected to switch 1, or interface connected to switch 2, or interface connected to switch 3? Where do we apply this? Let me see if anyone is sharp enough to... Where do we apply it? Nobody?
Interface to switch.
Interface to switch what?
Switch 3.
Okay, switch 3. Okay. Now, somebody says interface to switch 3. Now, is it going to be in or out? Is it going to be in or out?
In.
It's going to be in.
Okay. When you say in, that means you are saying the traffic is coming inside this router from switch 3. Is that what you mean?
No, out, sir, out.
Is out, sir.
So if you say out, that means the traffic is coming out from router 1 to switch 3. So let's find out. Let's find out what we're going to do. All right. It says, let me see, where is it? Okay, look at it. Aha. It says apply the access list outbound on fast Ethernet 01. Which one is fast Ethernet 01? Let's see. Let me see the router. Okay, so you see fast Ethernet 01 is connected to 200.1. All right, so let me see 200.1. So it's to switch 3. So you guys are correct. Okay, so what we will now do is we will enter inside this router and go to the interface connected to switch 3. So this is the router here. So I'm going to exit here. I'm in the global mode. First of all, if I do show run, is going to, show run is going to show me, this is like show running configuration. If I say show running configuration is just a command to show me what is already configured on the router. Okay, so I want to check to be sure our access list is there. Yes, see our access list. You see, this is our access list. Now, we need to look at the interfaces. All right, so this is the interface that is connected to the switch 3 that we talked about. All right, it's connected to fast Ethernet 0/1. Right? How do I know it's connected to switch 3? The IP address 192.168.200.1 is sitting on the file server network. Can you see file server here? File server is connected 200.100. So which means they are all within here, right? So what we will do, we need to enter into this interface fast Ethernet 0/1. Okay. So if we enter it, you will see this prompt will change. There will be IF there. So I will say interface fast Ethernet 0/1. Good. So if I press enter, you will see the prompt has changed for me here. So what I'm going to do, I will now apply it. Can you see? IP access group, then the name that we have created. Then we're using what? Out. Okay. So remember, sometimes I copy it for case sensitive so that you will not make mistake. Right? So if I say IP access group, then I will now put the group name we have created. This is the group name we have created. Let me paste it here. This is it. Then, assuming I don't know what, if I put a question mark, you see it will tell me, ask me whether it is inbound or it is outbound. So you see, we all agreed that it is coming out, right? So I'm going to now put out. Good. See, the moment I did that, you see our completion comes up to 100. So we're going to now run the test that we did earlier on. Remember, the test we did earlier on showed us that all these three systems are able to access the file server. So now we were supposed to only permit this PC1. So we will run the test again. And then, in fact, let me put it on simulation mode so that you will see this is simulation. So that you will see how the packet is moving. All right. So we'll run the test again. All right. So we're pinging 200 or 100. Very good. All right. So the packet is coming from PC1 here. Is that not so? And then, so it's going to go here. And then it will get to the router. From the router, it will go to switch 3. And from switch 3, it will go to the file server. And then it will now go back. All right. So you see, it will go back. That is the reply now, which means the traffic is completed. It is able to go. So you see, it's giving us the details here. Okay. So, and then it will come to PC1, and then we have a tick. Very good. That means our pinging was successful, right? Now, we will now do the same mode for PC0. We are going to run the same command for PC0, and we should not be able to get reply. Okay. So this is PC0 here. If I run this, it comes to the switch. And then it goes to the router. Now, it should not be able to come out. Can you see? It's clicking X there. It should not be able to come out. Now, when we come to PC2, we'll run the same thing. If it gets to the router there, it should not be able to come out. Okay, run it. Okay. So it goes. Once it gets to the router, it should fail there. You do X. It cannot be able to work. It will go back and tell the PC, this thing is not working, no. The traffic is not going, no. You see? So that is what happens. Because we have created an access list to only permit traffic from this to come here. Any other one is denied, right? So we will check our results here. Assessment, everything is fine. Okay. Very good. Now, let me close this and see if we can try one more packet tracer. Or do we call it a day so that tomorrow we do more? What do you guys think?
Yeah, let's call it a day.
All right. So we will call it a day from here. And then tomorrow we'll do more. And I'll encourage you to do these activities on your own, so that you'll be able to get proper understanding. Any question? Any question? So I'll be posting the recording on the website, and I'll send you the link. Please, when you go through it on the YouTube, click subscribe and then also click the notification bell, because some of you have been sending me notice that I should be reminding you anytime I post a video we've uploaded. So, but if you click the notification and you subscribe, anytime we upload the video, you will get a notification automatically. All right. So please do that. Thank you. So I think that will be all for today. Okay, yes, there's someone that I've been trying that has a problem. I think it's Daniel Einaya. Daniel Einaya, once the class is over, you can remain back, and then I can be able to hear from you. So class, I think I will be able to dismiss you guys from here. Good night. See you guys tomorrow by 6 p.m. Okay? Tomorrow by 6 p.m. Thank you.